So the Glossopteris is a fern-like plant, and this plant cannot live in salt water. So for this plant to pollinate and grow in all of these different areas, it had to be a solid continent. It could not fly over oceans. All right, Lystrosaurus, another animal that walked on land. So you got the Lystrosaurus in Africa, India, and Antarctica. Sorry, the Cygnethus was not in Antarctica, as I said before. All right, but the Lystrosaurus is. And then last, the Mesosaurus. Now, you look at the Mesosaurus, like, oh, that one can swim. It was a freshwater dinosaur, and it could not swim over long distances. So, for the Mesosaurus to be in Africa and South America, it would had to have been close together. Now, one thing that some of you might have noticed right now, is Antarctica. Where is Antarctica now? It is nowhere near these other continents. And what is the climate? We've learned about climates. What is the climate of it? Very, very cold. This fern would not survive there. The Lystrosaurus would not survive there in these conditions, which gives us evidence that Antarctica was much, much further north than it is now. Antarctica has, over the millions of years, migrated south. All evidence. Rock sequences. As we were looking at the shorelines, let me go back for a second. Here, look at the shoreline here and the shoreline here. Now that they're apart, these shorelines have similar rock layers, like very similar rock layers. So all of this here is on both of the continents. These continents are hundreds, if not thousands, of miles away from each other now. For that to happen the same on two continents is impossible unless they were together and these materials were deposited at the same time. Okay? There is no way that you could have two separate continents with an ocean in between it and have the exact same rock layers. It is not possible. So that's another evidence, the rock sequences. Glaciation. If we're looking at the glaciers, see here the lines? Those striations, those scratches, don't line up. If we put them together, they do. We had a big continental glacier right in the middle, and as it squeezed out in all directions, you have the striations or the striation pattern that lines up. Another evidence of continental drift. All right. Now, back in the day, there was this guy named Wegener. Okay. Wegener came up with continental drift, but he didn't really understand it. He thought that this continental crust plowed through or pushed through the oceanic crust, which really didn't make sense. Then Holmes came in, and Holmes is the one who figured out the convection currents and that the continental plates are, or the plates themselves, are floating on top of that plastic mantle and moving that way, which helps to prove continental drift. Now, this one's a little difficult. What actually happens is, you know what, I'm going to wait the next slide on this one, ladies and gentlemen, because this is going to take a bit. So we're going to stop here, go back, review the stuff we did, and I'm going to dedicate the whole next video to the magnetic stripping, or what we call pole reversal.